Hello everyone. In this video I would like to talk about again on the battery extension module that I'm planning to do in my Volkswagen e-up second generation, and I would like to explain you what is my main concept of doing the battery and show you my module designs from which I will choose one. So the first thing that I would like to talk about is the security of the battery. I will do my best to engineer the battery in such a way that it will be with maximum security. What do I mean is that the battery should be resistant to vibrations, because in the car here there is a lot of vibration when we're driving. So that's why I will design the pack the way that it should resist vibration. The second bullet about the safety is the battery temperature. I will do my best the battery temperature to resist cold weather. I have put a threshold of -10°C, so the battery should work normally in -10°C. If you live in a colder area, I think this won't fit you. But still, I'm planning to do so. For this reason, I have researched will be the best chemistry of the battery. For now, the safest batteries are lithium iron phosphate batteries, which can be charged and discharged with minus temperatures. But having a battery with different chemistry from the one that is in the car will cause some problems. That's why I will stick with the lithium iron batteries, and we'll try to isolate them as much as possible to be isolated from the external for the ambient temperature. The third bullet on the safety concept will be the battery should be waterproofed. Some of you point me out that in some of the homemade battery extensions for Nissan Leaf, the whole car burned because just the water flows into the extension battery, and because there is a high voltage there, sparks can occur and fire can also occur, which leads to burning the whole car. So this should be also considered, the battery to be waterproofed. And the fourth point that I'll consider is how to cool or heat the battery if needed. This is something that I also think when I'm designing the battery as a whole. One guy also pointed me out that if we're making a battery which have a different internal resistance than the battery in the car, and we connect both in parallel, it will be some transfer of power between the batteries, and I think that point is valid, and I think this should be concerned also. But if this happens and this prevents me to connect the battery in parallel to the battery in the car, I'm considering connecting the battery to the heater of the car. So this way it will not interact with the internal battery resistance of the battery in the car. Or I can connect this battery, the extended one, with the DC-to-DC converter. Whenever you turn on the car, you will see, if you have some OBD reader, that the car have around 400 to 500 watts power consumption only for the low power electronics of the car. So let me stop talking about that for now. This is all for the first concept, this concept that I should consider safety first, and the second concept to build the battery will be to be easy built. It should be very easy everyone to build it. So let me show you now what is my modules that I thought about, and I will very much appreciate if you have any comments or suggestions, just to leave in the video description below. My first design was to do a brick like that. It will be 14 cells in series and 7 cells in parallel, but I can modify the cells in parallel in order to fit the maximum amount of cells in the spare wheel department there. This actually is around 1 kilowatt of brick. It will use one end for the positive, the other end for the negative, and I have to connect all of these together, and on the other side to make one giant pack like this, which will be, as I said, 1 kilowatt of energy. The pros of this build is that it will resist vibration. It's very stable, like a brick. It's very compact. You have a lot of energy in a very small amount of space. But the problems in this build is that whenever you measure the voltage between the positive and the negative, you will see that it will be around 50 volts, which is enough to hit you. And there's a danger whenever you build modules like this. I have to build 6 modules like this, so there will be a risk of hitting me by the voltage here. The other problem is that this is very hard to build. We have to solder everything, every single cell of this on the other side, on the one side and on the other side. That's why it's very hard to build. And also in this high cell configuration, there is a very limited amount of hardware that we can use for the BMS and for the active balancer. So let me show you how this fits in the department here. You can see it's fitting well. I can adjust the cells in parallel to build to fill the whole space here, and I also I can put another layer here on top of this, so I can make 3 cells on the bottom, 3 models like this on the bottom and 3 on the top, to form 6 models like this. That will bring me around 84 batteries, 84 cells. So let me now show you my next design. My next design was just improved version of the previous one. I reduced the number of cells to 7 in series. So you can see here 7 cells in series, and I have 8 cells in parallel. This will bring me around 550 watts per module like this, per brick like this. It has the same pros and cons like the previous one, except that it is low voltage. You can measure between the positive and the negative part, depending how you're connecting it, around 24-25 volts, so that's not dangerous for the skin, and for you, you'll not feel it if you accidentally touch it. So here we have low voltage as a pros. There's a variety of components that can be used in 7 cell configuration. It's compact and it resists vibration. The main cons here is that, again, it is very hard to build, because we have to solder every single cell on the one side and on the other side. I'll just place it here on the compartments, and we'll show you how they can fit on 2 layers, and there is actually space for cover. So this is my my fourth solution for modules. Actually, this is not my design. I bought this from AliExpress. I will put a link to the video description if you want to play with that. But PCB like this, and soldered 18650 holders like that on both sides. And if you want to build a to just follow the instruction, this is the minus here, this is the plus. You have cell and put it like that. Then take another cell, minus, put it like that. Another cell, put it like that. Another one, and so on and so forth until you reach to the last one. This is how easy I built 770 watts battery. If I will have a module of 140 watts, and it's absolutely easy everyone to build. You just need to pop the cells in this module and then you have a battery, and they can stick together one over another. Let me show. This is how they stick together. I will not energize this module because this will be it will be heavy for me and it will be difficult to show you, but they connect to each other. I think it's the same. Yes, this is the plus, this is the minus. They connect to each other with these standoffs here, and this one, the plus, the minus, and the whole cells connect to each other with these connectors here. There's a fuse here, and this can stack very easily. To build more modules like that, we need to connect the minus with the positive of the next module, and so on and so forth, to make 84 cells. Let me show you how. So I don't know if you can see it, but let me show you like that. There is plenty of room for cover and to build more modules like that. So I'm planning to fit here 12 modules like this, and I think I will fit here around 10 kilowatts of this kind of modules. So for now I will start with this design to see how it will fit, and then I'll continue. If there's a problem with this design, I will choose another one. One of the problems of this design I found recently is that there is 2 layers of batteries, and when you place them, let me show you on the other one, if you place the battery on the bottom here, there will not be resistance to vibration, because if it will vibrate, the battery will get loosened and will be disconnected. That single layer of battery will be placed vertically on top of each layer, and this way I will do the vibration resistance of these modules. So this design will definitely fit here in the spare wheel department. There is a lot of room, actually, you can see it, but for now it's okay to be like that. When I have the first prototype, I will decide how to place them and how to arrange them to fit as much batteries here as possible. Let me show you how easy and quick it is to build a module like that. To build 420 watts module, first you take one cell like this. As I said, they are sold from AliExpress. You will receive it like this. Then this is the positive, this is the negative terminal. I will put a screw like that, and then a standoff on top of that. It's a plastic screw, and where I will put the standoff. Then on the other side do the same, plastic screw and then standoff. The other side, again, the same. Before you start building module bigger module like than one PCB, you just need to populate the cells first, because then you will not be able to populate the cells. And when all the standoffs are done, you take the other module, make sure that the positive and negative match the positive and negative on the other module, and you just place it like that. Then they are connected, and on top of that you put a standoff, another standoff, on the other side the same. Again, don't forget to populate the batteries here, the same. Then take the next module, be sure to have the same orientation, stack it like that, and here you can place plastic screws, or you can build bigger module, it's up to you, but for now I'll just put the plastic screws here. And I think you get the point how easy it is to build this kind of battery. This is 420 watts, 7S, 24 volts. Then you have to connect, there's a cable that they are also selling that you have to connect one cell with the other cell, and so on. This is a ribbon cable that connects all of the modules. Personally, I don't like this connection. I prefer to have GST connection, but I can change this later on. This is all for this video. These are my 4 suggestions for design for the modules. If you have some more options or comments or suggestions, please leave them in the comments below this video, so that we can discuss them and see which are the benefits, some pros and cons of your suggestions. Okay, that's it. I hope you like this video. If you like it, give me a thumbs up. Don't forget to subscribe to my channel. See you soon.